All right. Greetings, wonderful people. We're going to continue from yesterday. So this will be part 2 of the apply strategies to solve quadratic problems. All right, so quick rundown. Don't forget to use these strategies when using word problems, and that is to familiarize yourself. So what is being asked? You know, what do you need to know in order to solve this problem? What information might you need? So in some of these, you might need a formula, such as an area, or as we saw yesterday, the area of a triangle formula. So some of these you might need to know some background information before beginning. All right, and that's a pretty big step. Translate, so basically do math stuff with it. Solve, you know, get what you're looking for. Check it, so checking it, does it make sense, right? So yesterday we had a lot of problems, we had a lot of potential solutions that we had, but we had no, well, when you really look at them, they don't make any sense. So yeah, and then plug it back in, especially with these kind of problems that we're working with today. If you plug them back in, it's a way of verifying that you have the right answer. Because even though mathematically you do something and you plug it back in and you notice, wait a minute, that doesn't quite seem right. And there was one problem, I think it was, I don't remember if it was this one or, I think it was this one here. So it was, it turned out it was neither of the problems solutions. So we actually had to kind of plug it into both of them to get both solutions. So that's a good opportunity to see that you're supposed to check it and plug it in to see if it makes sense. And lastly, state your answer in given units, which, you know, sometimes I'm a little bit bad at, but oh well. All right, so some more strategies you could use for familiarizing, and that is to draw a picture, a diagram, or a graph. So drawing something helps, and you don't have to be a great artist or anything to draw. You're just trying to get an idea of what you're looking for. Well, you could also make a list out what you know and list out what you can do with those so that you can get to your solution. Look for any clues that they give you. So again, I know one thing that students usually do is number surfing, and that is they look for numbers and then they think of what to do with them. All right, there is not always a clear path from what you are given to what you need to get. And then here we got estimate to get an idea. So we want to know kind of what it's going to be like. And then we underline keywords if we can. So again, I have a short list of keywords that you might run into. So let's go ahead and get ready to go into where we left off. So we only have this many here. So you can take a picture of this or do something else. Anyway, so the height of a rectangular prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. If the volume of the prism is 198 feet cubed, what is the value of x? All right, so in this case here, let's see, a rectangular prism. So, and again, you don't need to be a good artist or anything. Oopsie. Always hard to get the up and down lines just right. So it probably looks something like this. In fact, you know, let's see if I can draw this extra. Not the best, but again, you don't have to be the best drawer. You just have to do something so that you get something that you can work with. So we have width, length, and height of this thing here. So the length and width can be expressed as, so it says here, length is x minus 1. And the other side here is x plus 4. If the volume of the prism is 198 feet cubed, so volume equals 198. Find the value of x, and I'm guessing that we are going to need something. Oh wait, hold on. It does say that if we look at this, it says the rectangular prism is 3 feet in height. So height is 3 feet. So sometimes you got to reread these things a little bit over. I don't know how I almost missed that, but that's okay though. It's a good way to see the strategies in action. All right, so what this is, the volume of this prism is length times height times width. So those three things multiplied together. So basically we're just multiplying this, this, and this so that it comes out to this. So let's go ahead and set that up. So I'm going to put this first. And we're going to have it equal out to 198. All right, about as best as we can do. Let me go ahead and use the FOIL method because I want to get this evaluated for the two parentheses. So x times x is x squared. X times 4 is 4x. Inside is minus 1x. So 4x minus 1x is 3x. And lastly, last two numbers, -1 times 4 is going to be -4 equals 198. So yesterday, I think we had another problem that was similar to this, sorry. And that is where we have a number on the outside. So rather than multiply everything, so if I did multiply, 3 times everything, I would have to divide everything by 3. But I can just cut that out and then just go straight to dividing everything by 3. So that would still have the same effect of getting 3 out of all these numbers. And it's always good to get 3 out of your a value. So if you have an a value, like in this case I would if I had to multiply 3 times x squared, I'd have a 3x squared here. That's always not a good thing to have. So in this case here, let's see, 198 divided by 3 would be 66. And now I have to move everything to one side. So I'm going to go ahead and minus 66 from both sides. And that will have the effect of moving everything to one side. And this would be -70. And as with most word problems, I like to see if we can multiply, factor, getting a little bit ahead of myself here. But I am looking for two numbers that multiply to 70, or actually I should be more specific and say -70. So two numbers that multiply to -70, but if I were to add those same two numbers together, well, I would actually have to subtract 1, because don't forget, if this is a negative, that means there is a positive and a negative. So that tells you that these two signs in each of the parentheses will be different. Now, I need two numbers that can multiply to 70 with a difference of 3. And this one's a pretty easy one, because if I ask most students, just, give me two numbers that multiply to 70 right off the top of your head, I'm going to get 10 and 7. So that was pretty easy to get that. So 10 and 7. Now, remember, whenever they are different, your middle term is going to tell you which one is the bigger one. So in this case, the bigger one is the positive. So if we can double check it really quick just to make sure we're not going to make any mistakes. X times x is x squared, okay. -7x plus 10x is 3x, so that makes the middle term. And 10 times -7 is -70. So yes, this looks like it's going to work out. And I'm going to go ahead and solve both sides, because the whole reason we moved everything to one side was so that we could use the zero product property. Now I'm also going to have to minus 10 from both sides here, and I'm also going to have to add 7 to both sides here. So this should give me my possible solutions. So my possible solution here, it looks like x is -10 and 7. Now, if I plug in negative 10 into these numbers, it's not going to work out. If I plug in negative 10, it would be something like negative 6 times negative 11. And, well, I don't know what it's going to come out to be. But either way, it would be an extraneous solution because you cannot have a negative distance to begin with. You know, actually, I'm kind of curious. I wonder if it would work out that way. Let me just go ahead and grab my calculator really quick and see if it would still work out if I plugged in negative 10. So that was negative 6 times negative 11. I guess it would work out because the two negatives would cancel each other out. But again, you cannot have a negative distance. So you could not have a wall of negative 6 units, negative 6 feet. So even though mathematically it works out, the answer does not make sense. And that's why it's an extraneous solution. And the question says, find the value of x. It doesn't say anything like find the height or find the width or find the length. If we had to do either of those, we would plug it back in here and see if it worked out, which in this case, we are not looking for that. So x is equal to 7, and that is the answer that we have for this one. Okay, let's get ready to move on to the next one. All right, so here we have Ken has a rectangular shaped vegetable garden that is 15 by 9 feet. He would like to increase the width and length by the same amount. So x. And he wants to make it so the garden is twice the size of the current area. Find the value of x to the nearest tenth of a foot. All right, so we got to, again, we're looking for x. So we're not really looking for, the length or the width of the garden. So he wants to make it double the size. So again, let's go ahead and I'm going to make a diagram here. And again, maybe you can get along without it. That's okay. And we need one that's about twice the size. And I don't know if that's going to be twice the area. And it says here that it is 15 by 9. And let's see, does it say how? Well, it doesn't say how much area it is. But if you were to multiply those two numbers together, you would get 135 feet in area. And it says here he'd like to increase this length and width by the same amount. So this would be x plus 15 or 15 plus x. I guess we'll go ahead and say x. Well, I guess it wouldn't really matter. We could say x plus 15 or 15 plus x. It would still come out to be roughly the same amount. And on this side here, we have 9 plus x because we are increasing it by the same amount. So if we increase this by x, we would increase this by x. That way, they're, again, increase the length and width by the same amount. And we need it to be twice the area. So twice the area, so 135 times 2. Let's see, 35 times 2 is 70. Double 100, so you have 270 feet in area. Okay, so it looks like in this case here, this will be the new garden size. And we need to find out what x will become. And I think I want to switch it back. Instead of 15 plus x, I'm going to use my commutative property. And I'm going to reverse it just because I think this is the way most quadratics look like. And I wrote it this way, 15 plus x, because I thought it would make more sense to people looking at it, because you're starting with 9 feet, right? And we want to add length or width to it to get to a higher one. But since we're working with quadratics, I'm going to flip it around so that way it looks more similar to what we are already working with. So this needs to come out to be 270. So let's go ahead and multiply this out using our FOIL. And we have x times x, which is x squared. And I'm going to go ahead and kind of use this middle step here, x9, or sorry, 9x plus 15x. So that would be 24x. And then 15 times 9 is 135. And this somehow still has to come out to 270. But it looks like I'm going to have to minus 270 from both sides. Now again, 270 is double 135. So if I minus 270, it would be negative 135. Oopsie, 135. There we go. Now we set it equal to 0. And we could try multiplying numbers to get 135, which I think we could try that. So I need two numbers that multiply, so 135 divided by, and let's see if we can get something. Let's try 5 maybe. And we get 27, which 5 times 27 is going to work out, but 27 minus 5 is not 24. So it's not 5. Well, let's try 135 divided by 4. And that is also not going to work, because in this case I get 33.75. And if I were to minus 4, I would not get 24. So this tells us that it is likely going to be a number in between integers, so a decimal number. So factoring is not going to work for this one, and I know that because 135 does not have a lot of integer factors. Well, none that will come out to 124. I'm sorry, just the number 124. Why do I keep saying 124? Probably because I almost called this, I almost forgot to call this one 135. Anyway, so factoring is not going to work on this one. So it looks like we are just going to have to use quadratic formula. So quadratic formula, and I'm not going to write it on this one here because that would take a while. So negative 24. So we have negative b plus and minus the square root of b square minus 4ac, which in this case is 135. Now we've already had a couple of chapters on quadratic formula, so I'm going to go ahead and kind of get this done a little bit quicker. So I'm going to kind of skip some of the explanation. But either way, there we go. We set it up, and I'm going to double check this just to make sure we have everything in the right place. Let's see, 24 squared. Okay, so let me go ahead and go back to the calculator, and 24 times 24. So that would be 576. Now we can also do the 4ac part here. So the 4ac, and that's going to be, okay, so negative 4 times negative 135. So, but negative times negative is going to be positive. So let's just forget the positive, and 4 times 135, which is 540, plus the last number we just got, which is 576, and that becomes 1,116. So let's see, negative 24 plus and minus the square root of 1,116. Man, I'm just so not getting my numbers right today. Still morning time. I probably did not get my coffee or something. Must be missing something. Oh, since we got to take the square root of it, let me go ahead and take the square root now. And if we read the question in the, or for the word problem, it says to round it to the nearest 1/10 of a foot, which is kind of a hint that we are going to end up with a decimal number. And anytime you're working with radicals, you run the risk of getting a non-repeating irrational number. I'm sorry. Yeah, non-repeating non-terminating. So in other words, a big mess of a number. So let me go ahead and put that number down right here. So we have negative 24 plus and minus 33.4066, and that's about as much as I remember. And we'll round it in the last step because there's always the risk that we may end up with something else. Now, here, I don't want to waste too much time, so I'm going to do a little bit of planning ahead. So if I have negative 24 minus 33, you know, that's going to be like, that's going to be a negative number, which by now we should already kind of know that we cannot have a negative number. So we are going to go with the plus option. So this would be positive 33.4 minus 24. So just so, because I'm going to keep my calculator, okay, I'm going to go back to the calculator. We didn't change anything, right? It's the number is still there. It's still the 33.4066, but we're going to minus 24 because one of the options we had was to add or subtract it, which actually that would be add 33 or minus 33. But either way, then the 24 will be negative. So in this case here, we end up with 9.40. Now, remembering back to the formula we were just working on, that's still all over 2. So we have to divide this by 2, and now we get 4.70. And since we have to round it to the nearest tenth of a foot, that's going to be right here, 4.8. Oh, wait, hold on, 4.7. We don't need to round it up because this number is 0. So actually it would stay 4.7. All right, 4.7 it is. And again, we already know the other side should be extraneous. X equals 4.7. And I'm going to go ahead and spell out the feet, which I don't know if I did the last one. In fact, let me go back to the last problem in a second and see if I forgot to put the units on there. In honesty, I'm a little bit bad at that myself. And I know there's sort of a meme that goes around that talks about teachers, you know, why does the units matter, or something like, you know, they make fun of why the teacher requires you to put the units in there. And that is because sometimes you are dealing with multiple units, okay? And the really good example of this would be, I forget which one exactly it was, but it was one of the Mars landers, one of the Mars rovers. You know, that little thing that they send to Mars. It crashed into the planet, I believe, because they had 2 teams working on the thing, and one team was using meters and the metric system, and the other team was using the imperial foot system. So somewhere in there, something didn't add up, and the Mars lander blew up or crashed. But that's a really good explanation of why it's important to put your units in there. And like I said, I'm a little bit bad at it too, but just make sure you go back and check some of these. I think I even missed some yesterday where I did not put the units on there. Okay, anyway, let's go ahead and get to the next one. And it looks like we only have 2 more after this. Although I looked at the packet earlier, and I think I'm gonna kind of work something out with these last ones here. Okay, so let's look at this one here. So given the diagram below, if the shaded area is 59 inches squared, what are the dimensions of the outside rectangle? So that means we're looking for this one. We want to know what are the dimensions. So once we figure out what x is, we have to plug it back in to get the dimensions. So we're looking for the actual length and actual width. Now for this one here, this is one of those questions that even if it's a simpler one, I always get questions on it. So let me see. One of the other things that we could do, let me see if I can go back to one of my other slides. Oops, not this one. Let's see, not this one here. Or was it this one here? Oh, estimate to get an idea, okay? So we're gonna use this one a little bit different than we might otherwise use. We're gonna estimate to try and get an idea of what we're supposed to do with this one here. So again, I get students that get stuck on this kind of problem all the time. So let's try to get an easier example. So let's say that I have a, let's say 2 by x. We don't know what it is. So I'm gonna just make it simpler. Okay, I'm gonna give you a simple example so that you can see what's going on. All right, so here we have here 2 and x. So we know that if we have 2 times x, that equals 10, right? And we have a shaded area here. And we have a square missing, right? So we took a piece out of the square. In fact, you know what, let me make it even simpler and say that we do know what x is. Let's say it's a 2 by 5, because that would equal 10. And we want the shaded area, okay? And this shaded area is missing a 1 by 1. So 1 by 1 equals 1. So again, I'm trying to keep this really simple. How much area is this shaded area? All right, you got it? Because it would be 9. Because you just subtract the missing area from the larger shape. So this would be 10 minus 9. I'm sorry, 10 minus 1 is 9. Whew, man. I need that coffee to kick in now. I think this coffee I got this morning, I went to a different place for my coffee, and that's probably why I'm a little bit off today. I don't know. Anyway, you just minus it. So that's what we got to do. We got to minus all this stuff. Oops. Nope. Okay, never mind. I thought I could erase it a little bit easier. But that's just to give you an idea. So that's what I mean by estimate to get an idea. Come up with an easier example. Come up with an easier problem. If you don't understand what the problem is, ignore variables. And the best one that I like to use this on is to work on problems with fractions. Ignore the fractions. Just pretend the fractions aren't there. Just work with the whole numbers or round off the fractions. And now you have a much easier idea. You're like, oh, okay, now without the fractions, it's much more easier to understand, okay? It's much more simpler. Okay, so anyway, let's get back to this one here. So we gotta minus it. So take the big shape, and we are going to subtract the little shape. So this one seems like it's gonna be a bit of work. So there we go. Length times width of the outside shape minus the length and width of the inside shape. Okay, and this says here that the shaded region is 59. So if we, again, big shape minus little shape, the shaded area is 59. So what are the outside dimensions of, the dimensions of the outside rectangle? Man, I can't even talk regularly today. Whew. Okay, so let's go ahead and multiply this out. So 2 times x, so that'd be 2x. And then this would be outside numbers as 2x times 6, which would be 12x, minus 1x. So that would be plus 11x. Minus, and this one's easy because it's just -1 times 6, and that would be -6. All right, minus, and I could put these in parentheses, but We don't really need to. We're going to end up subtracting it anyway by other stuff. And I'm going to go ahead and multiply this. So x times x is x squared minus, because I'm going to have a minus here. But actually, ooh, you know what? Looking at it a little bit closer, I could have missed that here because I could have sworn that it might have been a bit different looking. All right, we still got a lot of stuff to take care of. So from here, we gotta combine our like terms. Combine the like terms. So 2. But actually, hold on a minute. Do I need these second parentheses? I was just talking about parentheses. Because here, I knew there was a trick that's going on with this 3x here. So it looks like actually I am going to need to keep these parentheses because these parentheses are actually going to be telling me that I am going to have to do something different. Now, if you remember from earlier lessons, I kept telling you to watch out for these negatives on the parentheses. I was hoping to have to avoid writing everything out over again, but I am going to have to minus this whole group. So when you minus the whole group, that means you got to minus this thing, and you have to minus this thing. And while I'm at it, I'm going to minus 59 from both sides. So if I minus 59 from both sides, it cancels on this side, but it comes back over on this side. So I am going to have to do some solving quadratics in order to make this work. So I have a whole bunch of stuff here. All right, so now we can start combining our like terms. So be careful, because sometimes those parentheses will make a difference. In this first one, didn't make a difference. The second one, because there was a negative, it does make a difference. If there was no negative here, I could have just gotten rid of the parentheses. But again, I got to be careful with this because I almost walked into that. Anyway, so let's go ahead and put these together. So I have combine everything. So 2x minus x. So that would be 1x squared plus, and we have 11 minus 3, which would be 8x. And regular numbers now. So -6 and -59. So that would be, don't forget 2 negatives make a bigger negative. There we go. I almost made this mistake because I didn't want to do an extra bit of writing, extra step, which I ended up having to do anyway. Okay, now we can start factoring this out. Okay, so I need two numbers that multiply to 65 with a difference of 8. Okay, so 65, and you know, just because we haven't done it in a while, I'm gonna go ahead and make a multiple list. And when I use the calculator, this is exactly what I'm doing. But let's see, 1 times 65, nope, they have a difference of 64. 2 times, well, actually that wouldn't really work out because 65 would have to be an even number. So we could go with 5 times 13. Let's see, 5 times 12 is 60. Yeah, okay, so it would be 13. Oh, it looks like we actually got it. I guess there are not that many factors. Okay, and it does have a difference of 8, so these are the factors that we're looking for. So let's go ahead and factor it out. So again, be careful because this is the first thing that you should look at. Or if you're using my method, what I call the reverse FOIL method, we need two numbers that multiply to -65. So we have 5 and 13. And again, this means they are going to be the same. So one is going to be positive, the other is going to be negative. And again, you can look at this one to get a hint on which one will be the positive, which is going to be the greater absolute value, or what I call the bigger one of the two. So 13 minus 5 is positive 8. So that works out -5 and positive 13, they will multiply to negative 65. So I'm going to go ahead and multiply those out. And we could double check it really quick, but I think we're on the right track here. Okay, so I'm going to go ahead and set both of them equal to 0 because that's why we need them to be set to 0, so we can use the 0 product property. Okay, add 5 to both sides here and minus 13 to both sides on this side here. So I'm going to go ahead and let's see, x plus 5, so that would cancel it here. So I get x is equal to 5, and over here I get negative 13 because this will cancel out and I get negative, or 0 minus 13 is going to be negative 13. But again, we get an extraneous solution because we cannot have a rectangle with negative 13, because right here, that would, if I plug it in there, I would get a width of negative 13, and that just doesn't make any sense. And again, if you plug in negative 13 mathematically, like if you're checking your answer, it probably will work out, okay? But again, it doesn't make sense. It doesn't pass the sniff test. If you sniff it, it just doesn't make sense. So certain things on word problems just don't make sense. Like again, cars that get 50 miles per gallon, unless it's a hybrid or a motorcycle or some kind of special car, it's usually not going to get more than 30. 30 miles per gallon is usually the highest you can get. Or, you know, like if someone said, I drove to Phoenix in 40 minutes from Tuba, yeah, that's not going to work. Unless you're in like a plane or something, you're not going to get there that fast. So certain things just don't work out. Anyway, so there we go. But again, it's not 5. Okay, so 5 is not what we're looking for. So that's why it's important to check it out. Because if I put 5, you know, if I said the length was 5, 5 inches, that's not going to work out. So in this case, because we got this as our answer does not necessarily mean that it is either of the solutions, because the question is, what are the dimensions of the outside rectangle? So I'm going to go ahead and label this outside. And I'm going to go ahead and put the length, and width. Okay, so the length, I'm going to plug in 5, and then we're only concerned with the outside triangle. We don't care about the inside triangle. The length is 5 plus 6, so that's 11. And the width is going to be 5 into this side here, so that's going to be 5 times 2, which is 10, minus 1. Oopsie, I meant to put that down here. And we could plug it into the middle shape here, the shape in the center of this one here, and see if it adds up to 59 to check it. But I think we're doing okay with this one here. But again, there's a bit of a lesson on that, and I think there was a question yesterday again that we did where this was neither of the solutions, right? And we checked it, it didn't work out. So that's why it's important to check it out, because if you check your own work, sometimes you'll notice that it's not working out. When it doesn't work out, that means you got to go back and figure out what's missing. What do we not have? And this kind of bugs me now. I don't know why it bugs me all of a sudden. I'm usually not really big on grammar or anything like that. But there we go. So again, that's why it's important to check it, because you might get an answer that is actually not an answer. And that's why we call them answers or solutions, because this can be considered an answer, but this is the solution, okay? And just a quick recap, solution is what you need to put into the original problem to make it work, all right? Solution is what makes it work. Answer is what you get from working on something. So their solutions and answers are not the same thing, all right? So like if your tire goes flat on your car, changing your oil is an answer, but it is not the solution. Because the solution only fixes a certain type of problem, okay? I mean, yeah, okay, switching out your oil will improve your car, but it's not going to help the problem that's going on right now. Anyway, let me go ahead and move over to this one really quick. So find two consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. Wow, that was a mouthful. Oh boy. All right, so consecutive. So consecutive means one after the other, or I don't know if that's the actual definition. You know what, maybe this is a good idea to do some, and I encourage people, students, to always use their tools. So consecutive, let's see what the actual definition of consecutive is. The good thing about math is that it always usually follows the definition of its regular English counterpart. So like the way you would use consecutive in a regular everyday talk, in everyday speaking terms, you would still use it in math the same way. There are like a few words I can think of that don't really match what they say, like roots. Okay, maybe there's a way you can make it work out. But anyway, let's see. Unbroken logical sequence. Following continuously. So similar words are successive, succeeding, following, succession, running, one after the other, back to back, continuous, unbroken. So the main things we're looking at here is sequence. All right, so we're looking at things in a sequence, consequence. All right, so basically it means one after the other, unbroken. So this means that these two numbers are next to each other. So it says find two consecutive numbers that are next to each other. And now they also have to be positive and they have to be odd. So this means something like 1 and 3, or 3 and 5, or I'm just making some numbers up, 5 and 7. All right, so those are examples of continuous because after 1 comes 3. That's the next odd positive number. For 3, the next odd positive number after 3 is 5, and so on. So I do get questions about what the word consecutive means because I don't know how common it is for regular people to use them. I mean, I run into that word with regularity, but I understand that not everybody really uses that uses that verbiage a lot. All right, so let's go ahead and, okay, so the square of the smaller number, so there are two numbers. There is a smaller one, and I'm going to call this one the larger one. And it says median, and this is what I was talking about when I was reading it because okay, so we're still larger. Okay, so in this case, we're still talking about one of them. Okay, I'm thinking about the other problem actually. So larger number, we'll call that one X, and smaller one is X. Now again, if you look at this little sequence I have, right? So the difference between 1 and 3 is 2. They have a difference of 2, so X plus 2. Here, if I have 3, to get the next number, I would simply add 2. And if I was at 5, I would add 2 to get 7. So that's why we have this. And again, this is kind of a weird question. And what makes it even weirder is that they are going to square the smaller one. So we get X square. And they want us to compare that added to 3 times the larger integer. So 3 times the smaller number. But in this case, they're using the larger, so that means we have to use this one here. So that would be X plus 2. And I agree, this is a very confusing problem. And this is not a very typical problem that I think you would really run into on a daily basis or on a with any kind of regularity, actually. I mean, this question is so far out there. Anyway, let's go ahead and continue working with it anyway. So let's see, we have x squared plus 3x, and I'm going to go ahead and use my distributive property, 6 and 24. And it looks like I'm going to have to minus 24 from both sides. So minus 24 and minus 24. So x squared. Okay, let's see, plus 3x. And 6 minus 24 is negative 18. And again, I got to set it equal to 0. And this looks like we can easily factor it. So thinking about factors of 18, so 1 times 18, 2 times 9, 3 times 6. And I want the one that has a difference of 3, so that's going to be 3 and 6. Now again, they are going to be different. So one is positive, the other is negative. And since my middle term is positive, that means the larger number is going to be the positive and the smaller one is going to be the negative. All right, and then we got to get our first number, which is x times x, which is how we got x squared. Now again, I'm going to go ahead and just reverse these numbers. So we know that this first one's going to be x equals negative 6. And if I want to solve this one here, right, so x minus 3 equals 0, well, what does x have to be? It had to be positive 3, because 3 minus 3 equals 0. So positive 3. And again, since we're talking about positive numbers, right, because it says positive odd number, that means even though negative 6 might work in another type of equation, because it says positive, we ignore this one here. So in this case, you might actually, realistically, if it didn't say positive, you might get 2 types of solutions, 2 workable solutions. So in this case, we get 3. So 3 is the smaller number. And to get the larger number, we simply add 2 to it, and we would get 5. And it looks like we actually got it right here. So just by making a list, we were able to, well, we didn't really estimate. We weren't really trying to get the answer at this point. I was just trying to show you what consecutive meant. But it looks like it works out. So 3 and 5 are the numbers we are looking for. 3 and 5. You know, this looks kind of like an ordered pair, so I'm going to fix it. And I'm going to write it as an ampersand. There we go, 3 and 5. That way we know we're not we're not talking about an ordered pair. Or if I drew a plus in there, it would look like we were, you know, adding them together, which we're not adding them together. So I think this is probably one of the better ways to show the answer in this case here. All right, we're going to do the last one, and that will be it for today. So moving on to the last one. And here's another one that is similar to the other one we just got done. And again, I don't really like these kind of problems because they're just so out there and they're not really realistic. But you know, it's on the assignment, so we're going to cover it. Find 3 consecutive positive integers such that the product of the median integer and the largest integer is 72. All right, so median in this case is middle number. So 3 consecutive positive integers. Now, it doesn't say even or odd, so this means it could be something like 1, 2, 3, or 2, 3, 4, and it could also be 3, 4, 5. So consecutive, again, still one after the other. They are positive, and we don't need to worry about odd or even or anything like that. So let's go ahead and list out the variables. So let's see, what could I call this one? The least number, I guess, I don't know. Median is what they call it. And the largest is what I'm trying to stick with what they are calling it. And I guess I could use the word smallest. Did they use the word smallest? Okay, it doesn't say smallest here, but on the last one, they did call it the smallest. So I'm gonna go ahead and go with smallest. I'm just picking the same words they're using. Oopsie. So I'm trying to keep the vocabulary the same. And median, so in this case here, the next number is x plus 1. And the last one, the largest, would be x plus 2. So that's how we're going to write this out. So let's see, such that the product, so this means we're multiplying it, right? Because if we look at our listing here, product means that it's going to be a multiplication problem. So the product of the median and the largest is 72. So if I were to multiply these two together, I would get 72. X plus 1 and x plus 2 equals 72. So I'm going to go ahead and multiply this out using my FOIL method. So that would be x squared. And then x times 2 is 2x plus 1x. That would be 3x. And last numbers, 1 times 2 is going to be 2. And I'm also going to have to move these, move everything to one side. I think I can use factoring for this one. So far with most of these problems, we haven't run into anything that would be like irrational or anything like that. So I think so far with most of these factoring works out. There was only the one that kind of didn't work out, and that was because I knew there were no numbers we could multiply. But again, you can also use other types of methods. Okay, you don't have to just use factoring. I'm just using factoring because I think it's the fastest. So minus 72 from both sides, and we get negative 70. Maybe I'll put that down right here just to show what I did. Minus 72. And that will cancel it off of this side here. And now we get equals 0. So just remember, you have to set it equal to 0 if you're going to use most of the methods. I think square roots are the only ones that don't require you to put everything on one side. Okay, so now I need two numbers that multiply to 70. And in fact, I think we actually did something like this earlier. Two numbers that multiply to 70. Right here, that equal to 3. So we already know what our possible solutions would be. 10 and 7. And we know they're going to be different, so plus and minus. And let's see, here we're looking for positive 3, which would mean that the 10 is over here and the 7 is over here. So 10 minus 7 is 3, but 10 times negative 7 is negative 70. And I don't know if this is exactly the same as the one we were just looking at. Oh, okay, yeah, it is exactly from that step, it is exactly the same as the one we were looking at earlier. So in this case here, x is equal to negative 10 and negative 7. But again, it says positive numbers. I said positive. There we go. So if I were to add 7 to both sides, right? So if I had equals 0, so what number plus 10 equals 0? Well, negative 10 plus positive 10 is 0. So that's how we got here. 7 minus 7 equals 0. So that's how we got this 7 here. So we end up with 7. And remember, this says x. X equals 7. So we're not looking for the middle number. and we're not looking for the largest integer. So this means that we actually get the smaller number from solving it. So this means the number sequence that we're looking at. Oh wait, let's see. Find 3 consecutive numbers. Okay, so 3 consecutive positive numbers. So in this case, it'd be 7, 8, 9. Why was 7 afraid of 9? Oh, anyway. There you go, 7, 8, 9. And we could double check this too. So 8 and 9, multiply 8 times 9, you get 72. So we just checked it, and it literally took like 2 seconds to check it. So the middle and largest, yeah, they multiplied it 8 and 9. Anyway, so that's it for this one. So I had to break this lesson into 2 parts. It was actually quite a long problem, and I wanted to make sure I covered each of these, and I wanted to make sure that I covered as many of the steps on strategies for solving them. All right, so don't forget your strategies. And I know word problems are the biggest thing that students usually don't like. All right, but I want to remind you that in the real world, okay, so let me go ahead and back up. I'm going to tell you a story, and I know you're probably ready to go right now, but so I work at the college as well. So I've taught at the college for almost as long as I've been teaching high school students. Well, actually, no. I take that back. I've only been teaching high school students since 2013. Before that, I worked at a junior high level, and I even worked in kindergarten for a short time. But anyway, yeah, I've been teaching college way longer, so for about 10 years now. And I get women, middle-aged women, so in their 40s or 50s. And I remember when I first started teaching, I had this old lady, probably in her 50s, that goes, "Oh, I never used math, and I'm 50 years old. So you can't convince me that math is useful." So I was like, "Okay, well, where do you work?" "Oh, I work at the drive-thru at McDonald's." Okay, well, that's probably why you never had to use math. All right, and I didn't want to be smug. In fact, I didn't even say nothing. Well, I didn't say anything, because if I said nothing, then that means I didn't say nothing, which means I did say something. But, you know, just looking at the way this woman kind of talked, it's like, well, I don't need math because, you know, I have a very simple job where a computer does everything for me, and all I have to do is, you know, something simple. And I'm not ragging on people's job. I'm not saying that service industry jobs are not real jobs or anything like that. But I'm saying that if you want to get further in life, you got to use more tools, and math is just one tool. So just like any tool, it helps you do something, right? It helps you get a little bit further in life. It helps you get more out of life. So if you have no clue where to use math, then you are never going to use it because you don't know where to use it, all right? In real life, word problems are like hunters in ghillie suits, or like snipers, to use them probably more familiar to video gamers. You know, they're hidden. They're not just out in the open. You're never going to walk down the aisles of the supermarket and bam, quadratic formula pops out of nowhere. It never happens like that. If you are looking for opportunities to use math, if you don't know where they are, they're going to go right past you. You're going to end up paying more money at the bank because you don't know how to take loans. You don't know how to look for APR. You don't know how to, you know, shop for cars. You don't know how to do all this stuff. And these are all opportunities where, yeah, if you are not looking for opportunities to use math, if you are just a simpleton who never uses math, you are probably spending way more money in your lifetime than if you were to stop and think about it. Does this car get good miles per gallon? How much am I going to be, you know, besides buying the car, how much am I going to be needing for parts? How likely is this car going to be breaking down? Because if it breaks down more often, you will need to buy more parts. If it uses a lot of oil, you will need to be buying a lot of oil changes. Those are all things that you need to consider in buying a vehicle. And that's just one thing that you can do. All right. But again, most people don't think of this. They just look at the car. Ooh, that one's pretty. They buy it. And if they had bought something that would be lower maintenance, higher gas mileage, they would be saving money, thousands of dollars every year. So I always get people that say, you know, I'm not using math, so it's useless. All right, yeah, no, there are thousands of opportunities every year that just go right on past people to use math. So it's kind of like, I don't know, I always have this saying, and if you've ever watched that movie Training Day, which I was looking for earlier, I was looking for that picture of the guy sitting in his seat saying, well, I changed what he says, but he says, well, I said for him, math isn't about what you know, it's about what you do with it. So there you go, just a little talk about word problems, because I always get students that say, I'm good at math, but I suck at word problems. Okay, that's like saying I'm good at driving in video games, but I suck at driving in real life, okay? So you got to know what you're looking for. So that's why I kind of give these strategies out, right? So you got to make sure you know what's being asked. And this doesn't have to just go with math either. This goes with all sorts of problems, okay? You know, what are you working with? What do you need? You know, how can we use what we have to get to where we need to go? That's pretty much all this step is. You know, start making a plan. Make a plan, you know, list out what you have. And again, your goals. You know, once you have your plan, what's the best way that it would probably work? What are some things that might get in the way? And does it make sense? Is that plan possible? Can you actually get what you need to out of that plan? Does the math work out? You know, if there is math. And lastly, you know, give your answer in a way that your reader could easily look at it and say, okay, well, now I know what the plan is. So anyway, I don't know if we have very many more opportunities to use word problems, so I thought I'd get this out of there. Plus that it's just pretty good to know all this sort of stuff. So just because it's math class doesn't mean that you only learn math stuff. You learn all sorts of things. And if you're in my class regularly, I kind of talk about these small lessons all the time. But anyway, that's it for today. I'll go ahead and call this lesson today, and I will see you guys next time. Thanks for stopping by.